Okay. So for people watching the video, there was just a question about just a review of how to plot the graph of a polar equation. So I'll just do a snip of 15 through 20. And I'll talk about some general rules here. So the first rule, and this is what I did in the Zoom lecture, and this is a very special case, that if R is equal to A sine K theta, or R is equal to A cosine K theta, and it's really important that there's nothing added or subtracted at the end. Or beginning. I'll just say nothing added or subtracted. Then if K is, well, if K is a whole number, and K is odd, the graph has that number of petals. That go out, I'll say absolute value of A units from the origin. So like the tips of the petals would be on a circle of radius absolute value of A. So like, for example, if K was 5 and A was 2, then there would be 5, and they're always going to be equally spaced. There would be 5 equally spaced petals that go out to a circle of radius 2. So I'm just going to do a really rough sketch. So say circle radius 1, circle radius 2. And then the center of the flower is going to be at the origin. Again, this is only if nothing is added or subtracted. And it depends on whether it's sine or cosine. So if it's cosine, right on the x-axis would be the tip of a petal, because cosine of 0 is 1. If it's, so I'm drawing the one for cosine. And then if it was sine and you plug in 0, you get 0. So sine would start at the origin and then you'd start making a petal, but cosine is going to start at the tip of a petal. And if they have to be equally spaced, and there are 5 petals, I just do 360 divided by 5. And I get 72. So the tips of the petals are spaced like 72 degrees apart. So let's see. So let's see, 0, 7. Normally we don't do angles in radians for, angles in degrees for polar coordinates. It's pretty much always radians. When you set up integrals, your angles have to be in radians, but just for graphing, only for graphing, we can do degrees. So it'd be 72, 144, 216, and then plus 72, 288. And then if you added 72 again, you'd get 360. So you'd be back at where you start. So those should be at the tips of the petals. So I don't know, 72, maybe about here, 144. So what's in the middle? here's 90 degrees, here's 180. The middle is 135. It'd be a little bit past that. 216. So this is like 225. So I don't know about right there. And then 288. This is 270 if we're talking degrees. And then the middle, 45 degrees, that would be 315. So it's a lot closer to the 270. So I think those are like where the tips of my petals should be. That's kind of a rough drawing, but yeah, so you should have 5 equally spaced petals. That's if K is odd. Now, what if K is even? Then the graph has twice that many petals. Again, equally spaced. And they should go out to a circle of, or they should go out absolute value of A units from the origin. So say we had a problem where it was 4 sine 4 theta. So that means 8 equally spaced petals. But this time it starts at it's going to start at the origin. And these should go out to a circle of radius 4. So 1, 2, 3, 4. Okay. What I might want to do is figure out where's the first like petal tip. So the first petal tip is when I have sine of pi over 2. Right? Because that's where sine is the biggest, is when you plug in pi over 2. When does the input equal pi over 2? So that would be when the input for sine is 4 theta. So it's when 4 theta equals pi over 2, and then just multiply both sides by 1/4. So theta equals pi over 8. And if you want, you can change that to degrees. So pi over 8 times 180 over pi. The pi's cancel. 180, oops, divided by 8. Oops. Is 22.5. And then if you divide the whole quadrant or the whole plane up into 8 equal pieces, this will tell you how far apart they need to be. So 360 divided by 8 is 45. So they should be 45 degrees apart. Okay. Well, 45 degrees, remember, cuts right through the center of the coordinate system, and half of that is 22.5. So the first petal tip is right here in the middle of that first half. And then if I go up 45 degrees, that would be right here. And then right here, just keep adding 45 degrees. So 1, 2, 3, 4, 5, 6, 7, 8, and then just kind of try to draw the petals. Okay, so those are special cases, right? When it's just a number times cosine k theta, a number times sine of k theta. What if they look different? Like, actually the first one, 15, r squared equals 5. So you would just get r equals plus or minus square root of 5, which means I'm just on a circle of radius root 5. And even if it doesn't matter whether you use plus or minus, you get the same graph. Because remember, suppose I do r equals square root of 5, which is about 2.2. Yeah, 2.24. So if I have my circle of radius 1, my circle of radius 2, my circle of radius 3, oops, I'd be about 1/4 of the way between 2 and 3. And then even if r was negative, remember if you switch r to be negative instead of positive, all that does is say, okay, just go into the opposite quadrant. So you would still get the same circle. So that's 15. If r is just a number, then it's a circle of that radius centered at the origin. 5 cosine theta. This fits that pattern. It would be the only thing is this circle only has one petal because the number in front of theta is 1, which is a whole number, and 1 is odd. So it would just have one petal. And I know when I plug in 0 for theta, I would get 5. By the time I plug in pi over 2, cosine of pi over 2 is 0. So like if I think about, here's pi over 2, but if I plug that in, I get 0. Radius of 0 means at the origin. And I'm only getting one petal. You might want to plug in like theta equals pi over 3. So I'd get r equals 5 cosine of pi over 3. Cosine of pi over 3 is 1/2. So I get 5/2. So that means if I go out along the pi over 3 ray, and pi over 3 is like 60 degrees, I don't know, maybe about right here, I would want to go out to a circle of radius 2.5. So 1, 2, 3, 4. So here's a circle of radius 2, circle of radius 3, and I want to be exactly halfway between them. And maybe you want to plug in a couple other points too to just see how far out you should go. What would happen is you would end up getting, that should be a circle, but there's like your one petal. So it's weird to think, how, well, if I only have one petal, I can't really have it equally spaced, right? So it just ends up being that right there. Here's the other thing you could do. Like if you're really uncomfortable with polar coordinates, you could say, well, how could I get this back in terms of rectangular coordinates? And I remember that in rectangular coordinates, x equals r cosine theta, y equals r sine theta. So if they tell me r equals 5 cosine theta. What I really want is r times cosine theta. So I could multiply both sides of this equation by r. So on the left, I would get r squared. And on the right, I get 5r cosine theta. Well, this part, that is x. And then remember, r squared in the polar coordinate system takes the place of x squared plus y squared. So if you're more comfortable looking at that, it's kind of a trick to know to multiply both sides by r. Well, then we would subtract the 5x from both sides. And then we could complete the square in x. Half of the middle coefficient would be -5/2, and then you square it and you get 25/4. And so then I could write this as x minus 5/2 in parentheses squared plus y squared, oops, equals 25/4. So that's a circle. And the center would be 5/2, 0. And the radius, r squared is 25/4. So the radius is the square root of that, which would be 5/2. And so that makes sense with the picture that I just drew, right? So the center is right there halfway between 0 and 5, which is 5/2. So yeah, and then the radius is 5/2. Right? And since the center is right on the x-axis, the y-coordinate is 0. So you can do it if you're comfortable with the polar coordinate system. You can do everything in the polar coordinate system. I just plug in values for theta and then get an answer, get a number answer for r. And I say, okay, what if I rotate that many radians from the positive x-axis? So I start out at the x, I rotate however many radians, and then go out to a circle of that radius. So you can do it that way by leaving everything in terms of polar coordinates, or you can find a way to switch to rectangular and then graph. Either way. That was 17. So let's look at 16. Okay. 16, r equals 4 secant theta. That like flower and petals thing, that only works for sine and cosine. It doesn't work for any other trig function. So you could use the same strategy that I talked about just a minute ago, where you just plug in different values of theta. So if I plug in theta equals 0, secant is the reciprocal of cosine. And since cosine of 0 is 1, secant of 0 is 1. So I would just get r equals 4. So that means on the x-axis, theta equals 0, I'd go out 4 units. And then I could say, okay, well, let's try plugging in theta equals pi/3. So I get r equals 4. Okay. Cosine of pi/3 is 1/2, and secant is the reciprocal. So it would be 2. So it'd be 4 times 2, or 8. Okay, so I have to make an angle of pi/3, which is 60 degrees. So I don't, oops, maybe a little bit more. And then go out to a circle of radius 8. So 1, 2, 3, 4. So there would be 8. So I'd want to go out to that circle of radius 8. My picture is bad. Let me It's really important to have an accurate picture in this one. So let's see. How do I want to draw this circle? Let's see if I can get I hate that this won't let me move it, or will it? Oh, it lets me move it a little bit. Oh, there we go. Okay, so I must not have done exactly 60 degrees. I should get my protractor out. Ooh. Okay, what's right here? So let's see if I get 60 degrees. It's actually right here. And I always provide, you know, well, for in person at least, you'll have those. So that would be this point right here. You could plug in another one. What you'll end up seeing is you do these different angles and you're getting points like this, and the graph starts to look like a vertical line, and you think, well, that seems weird. How am I getting a line from that? So then if you try the other strategy, so for secant theta, remember secant theta is the reciprocal of cosine. So this is the same as 4 over cosine theta. Well, what if I multiply both sides of that equation by cosine theta? Then I get r cosine theta equals 4, but r cosine theta, that is x, right? And x equals 4, that is a vertical line. So that really is the graph. So it starts to look like a vertical line. It really is a vertical line, which seems weird because you think secant is this weird graph that kind of looks like up and down parabolas. How are we getting that? Okay, so I've talked about 15, 16, 17, 18. Theta equals pi over 3. I was actually just talking about the graph of this with my calculus 3 class earlier this morning, but we were in 3 dimensions instead of 2 dimensions. So this just means, let me look back at this graph for a minute. For x equals 4, when we're in the rectangular coordinate system, then we got that vertical line, and y could be anything, right? I could go up as far as I want, down as far as I want. Since y isn't in the equation, y can be anything. So the idea here is r is not in the equation, so r can be anything. Which means I can be on a circle of any radius. I just always have to make an angle of pi over 3 with the positive, with the positive x-axis. So it doesn't matter what the radius of the circle is, I just always have to make a 60-degree angle. So if you look at that, you just say, okay, I can be on this circle, I can be on that circle, I can be on this circle. So you'll just get, and if you only did the first quadrant, that's fine. But technically you could even have negative values of r. So really you would get the whole line going both directions. But if you only did up and to the right, I would give full credit for that. Okay, so r squared cosine 2 theta equals 1. I think I do those in the completed notes, one of those. It's a little bit different. If it weren't, oh no, I think I had r squared equals cosine 2 theta. Let me check the completed notes. Okay, let's see. So 10.3 starts on page 17. Nope. Yeah. Okay. So let's look at one of those. Let's do the one that has that answer and then we'll check it. Okay, so let's look at 19. You can start out the same way. The important thing is that I do have to worry about signs, right? The right-hand side is 1. So it's always positive. And R squared is positive. So just for the signs, the SIG ends to work out, cosine 2 theta has to be positive. Because if it weren't, then we would have R squared times a negative equals positive 1. That can't happen. So cosine 2 theta has to be positive. So I asked myself, well, just where is regular cosine positive? So where is, I'll use a different letter. Where is cosine alpha positive? I think about the unit circle. It's positive in quadrants 1 and 4. So between, I'll just say negative pi over 2 to pi over 2. But I don't have cosine alpha, I have cosine 2 theta. So I'm just going to replace alpha with 2 theta. And then I would just multiply the whole thing by a half. And so I would get negative pi over 4 less than or equal to theta less than or equal to positive pi over 4. So when I plug things in, they just, for theta, they have to be between negative pi over 4 and pi over 4. So pi over 4 goes right through the middle of quadrant 1, and negative pi over 4 goes right through the middle of quadrant 4. Okay, well, it's easy to plug in 0, right? So I'll just plug in theta equals 0. And I get cosine of 0. So I just get R squared equals 1. So R is plus or minus 1. And R itself could be negative. That's fine. I just can't have the whole left-hand side be negative. So I could go to the right one or to the left one. Okay, what if I plug in, I'll see what happens if I plug in pi over 4. And actually, it doesn't matter whether you use positive or negative, because remember, cosine is an even function. So cosine of a positive number is the same as cosine of the negative of that same number. So it doesn't matter. Get the same answer for both plus and minus. So if theta is pi over 4, 2 times pi over 4 would be pi over 2. But that's 0. You'll never get anything for R to make it equal 1, right? This has no solution. There's nothing you can multiply 0 by to get 1 as the answer. Okay, so maybe I'll try maybe I'll try pi over 6. So I get r squared, and it could be plus or minus. R squared cosine 2 times pi over 6 would be pi over 3. Cosine of pi over 3 is a half. Right, we go this way. But you get the same thing if you go backwards, that angle, right? The x is the same. You get a half either way. So I get r squared times 1/2 equals 1. Multiply both sides by 2, you get r squared equals 2. So r equals plus or minus root 2. Okay, and that was when I plugged in pi over 6, which is 30 degrees. And square root of 2 is about like 1.4. So I'd go out to a circle. Well, if that's 1, here's 2. And so 1.4, I don't know, maybe a little bit smaller, but like right there. And then I would get the same thing if I went back. And then I'll just plug in one more thing and then kind of explain what's going to happen. So I'll plug in, so I've plugged in pi over 4, that didn't work. I plugged in pi over 6, that worked okay. You could either say, okay, I want to find what's happening between those two. My guess is it's just gonna kind of go like that. The real question for me is what's happening as we're getting close to the plus or minus pi over 4. So I would try to find something in between pi over 4 and pi over 6. And pi over 6 is the smaller of the two. Probably the easiest way to find it is to get a common denominator, which would be 12. Okay, well, there's not a nice whole number, right? Pi over 6 is 2 pi over 12. Pi over 4 is, 3 pi over 12. But if I go to 24, then we'll be able to get something. So just multiply top and bottom by 2. So 5 pi over 24. It seems like a weird angle, and it is, and I won't be able to find a nice answer without my calculator, but at least I know something to plug in. It should be like halfway between those two rays, halfway between the pi over 6 and the pi over 4 ray. So it's going to go there. So this will be like the 5 pi over 24. And I'm just going to use my calculator. Okay, so I get r squared times cosine of plus or minus 5 pi over 24. 1. So let's see. Make sure you're in radians mode. My calculator is currently in degree mode. Okay, so cosine of 5 pi over 24 is about 0.793. Divide both sides by 0.793. Take the square root. Getting 1.12. This is unexpected. Oh, I know what I did wrong. I forgot to multiply this by 2, right? It was 2 times that. So it really ends up being 5 pi over 12. Forgot to multiply by 2. Okay, so cosine 5 pi over 12. So I said, I'm getting something unexpected, because what I did not expect to happen is for it to suddenly turn around and get, closer to the origin, because the last one I got like about 1.4. It went out to a circle of radius 1.4. I wouldn't expect it to turn around and come back, right? Because I think the one where we got no solution, think of if you try to solve for r, you divide both sides by 0. And like when we graphed, when things were in terms of x and y, if you ever got 0 in the denominator, that's an asymptote. So I'm thinking that the plus or minus pi over 4, those are like asymptotes for our graph. So I'm expecting them to go out to plus or minus infinity. Okay, so now, yeah, this changes things a lot. I get my calculator is dying here. So 0.2588 about. And then I divide both sides by that. And I get about 3.8637. And then take the square root of that. So I get plus or minus about 1.97. So I'm almost out to a circle of radius 2 now. So I'm like right here. Right here. So notice that it's looking a lot like, if you've done your 10.5, it's looking a little bit like a hyperbola. Oh, and I'm forgetting to plot the negatives, right? So the negatives have to go into the opposite quadrant. So I would get this. Oops. Okay, let's go look and see what the answer is. Hyperbola. Center is the origin, foci on the x-axis. Okay, that makes sense because my hyperbola opened sideways. It's a little bit hard to see this by changing to rectangular coordinates. Yeah, I'm not going to talk about how we would do that, but I know this took a long time, and I am more like, I'm not going to have you draw graphs in general, but I will have you do graph matching, right? So you have to at least be able to pick out points. So what you could do is, if you're not totally sure, like, I don't know what this graph is supposed to look like, just pick values of theta to plug in and say, okay, if I go along that rate, I should be out 5 units or 2 units or something. And then that might just help you say, okay, well, that point isn't there, so it can't be this graph. Kind of like what I did there with earlier with the petals, where I said on the x-axis, I know I should be out 7 units, and not all of those graphs went out 7 units. So I was able to rule those out. I know that was a lot. I'm going to stop recording or pause recording.